Okay, guys, we're going to continue with lesson 4.03, the proofs. I was getting kind of rushed on time, so I have to split this up. Okay, let's go back to this example one and check it out. We're going to write a justification for each step, given that point B is the midpoint of AC and AB. So definition of midpoint tells me that this is congruent to this. Okay, so I'm starting off with B is the midpoint of AC. That was my given information. Now, I've put these notations on here that AB is congruent to BC, so that would be a statement, and I'm going to use definition of midpoint. Remember, if they tell you something's a midpoint, you're going to use definition of midpoint. Now, this is what I was talking about earlier. See, I've got given information here, and I've got it here as well. It is always at the start of the proof, but it can be broken up. I could have also put this with number 1, but it just makes more sense to separate it out here. Now I've been given that AB is congruent to EF. That was given information. Now look at this. I've got two different things congruent to the same thing. So I can state that they are congruent to each other by the transitive property of congruence. Okay, so our proofs always begin with our given, and then we work towards our prove statements. And let's look at another little example together. This one seems kind of redundant, but I'm given that I've got a segment XY. So I'm given that I have a segment XY. That's my information to start with. I'm going to prove that XY is congruent to XY. So that's going to be my last statement. So these are things I can fill in right here before I even start thinking about the proof. Okay, I'm given that I've got a segment XY. I know that XY is equal to itself because of the reflexive property of equality. Okay, well, when things are equal in measurement, that makes them congruent. So it's really, this one says definition of congruent segments. I always just write definition of congruency, which states that if you have equal measure, you are congruent. There's usually more than one way to do a proof. So now let's look at the second example. We're going to fill in the two-column proof. We're given that angles 1 and angles 2 are supplementary. And we are given that angles 2 and 3 are supplementary. So I have to prove that angle 1 is congruent to angle 3. Okay, what's my given information? This was all my given information. So this is what goes in blank number 1. It's listed here as A. Then they tell me, okay, the measure of angle 1 plus the measure of angle 2 equals 180, and the measure of angle 2 plus the measure of angle 3 equals 180. That's the definition of supplementary angles. So if you're given that something's supplementary, you're going to be using that definition. Okay, for 3, we have B. So now that I've got two different things here, measure of angle 1 plus the measure of angle 2, and then I've got measure of angle 2 plus the measure of angle 3. Two different things equal to the same thing. They've listed it as a substitution, but I would prefer we write our transitive property of equality here. Okay, and that allows me to make these two things equal to each other. Two different things equal to the same thing can be equal to each other. Now when it's listed like this, if I were to subtract the measure of angle 2 and subtract the measure of angle 2, I would be left with the measure of angle 1 equals the measure of angle 3. That's where I get the subtraction property of equality for right here for C. And then, now that they have the same measure, I could make the statement that they are congruent. That was what I was trying to prove. It's always my last statement. I could have filled this part in even if I didn't know anything else in the proof. I could have filled this part in even if I didn't know anything else in the proof. So now that I've got the same measure, I can say that they're congruent by the definition of congruency. Okay, I told you I would give you an example of a paragraph proof. Here's an example of this. It is not the typical way we do proofs. So now I'm given that BA is perpendicular to BC. Well, I know that perpendicular means they form a right angle. Okay, so I'm just marking that. Because BA and BC BA is perpendicular to BC, angle ABC is a right angle. And the measure equals 90 degrees. According to the angle addition postulate, we talked about that earlier in the year. We talked about the segment addition postulate as well, which just states that if one piece of the angle is added to the other piece of the angle, it equals the whole angle. So according to the angle addition postulate, the measure of angle 3 plus the measure of angle 4 equals the measure of angle ABC. So by the substitution property of equality, the measure of angle 3 plus the measure of angle 4 equals 90 degrees. I'm substituting this 90 degrees for the measure of angle ABC. And by definition, when two angles are added together that equal 90 degrees, by definition, angles 3 and angle 4 are complementary. So that would be a paragraph proof. You basically just write an explanation step by step. All right, guys, we're going to do some more practice for proofs later on. If you have any questions, hit me up on It's Learning or in class, and I will talk with you soon.